Hi guys, I welcome you to my channel. Today I'll be solving this word choice 2 problem. It's marked as hard, and this is the second question of try series in line 75 or the third question, and it is marked. It is hard indeed. So I try to solve using recursion. Like we have index this. Like we'll take all possible O and we'll try to check that if that is O is that O is basically I will go top left right bottom and try to find that if that character that word basically this word is in the board or not. So what is the question is saying that we will be given a m question matrix or board and a string of list of strings words. Okay, here list of strings word and we have board, so I have to find all we have to find that if I have to return which word is present in the board. This is the task. I have to pass the I have to return the word which is present in the board. Yeah. Okay. So how to solve this question? I have solved this question using recursion, but this recursion was giving me TLE time limit here. So analyze complexity. What is let's see. Server is busy. Okay. So this is very big code and it was giving me TLE over at 43 only. So we had to use try here. Try here, how we can do using try. So we are having a stream of characters, right? So try does the same. What we will do first, we will insert this word p, eat and rain on the tries prefix tree, and then we try to find that each word and see that each word and see that if that word is present in the board or not. So let's create a tree first, tree class. So we can do quickly class try node, and this is class we are creating. Now we are creating a constructor. I say init, it takes one variable self. I don't know, but yeah, this is how it should work. I will memorize this self dot children is equal to empty object, and self dot each word is last character or is just last is equal to false, the false. Now I'll try to insert word, and I'll check that I'll loop through the characters code ch in word, and if ch not in self dot children of ch will create a try node new try node. Creating new try node, basically new try node means this we are initializing with the new. So it will have two things, children, and it have second is last. So we have initialized it. Now we will move to that try node because uh, okay, we have to have some kind of node will be self. So node dot children and node dot children of ch. Now we'll update the node is equal to node of ch. Okay, and we'll mark that character as an end. So node of ch, node of as or node of is last true. Means this is the end of the word, and that's it. Now we have to write here a DFS. So first, writing DFS, what we have to do, I will find this row and column first. Int, not int, row is equal to board of length length of board calls is equal to length of board of 0, and now I loop through it here for I in range of rows, for j in range of calls, and for each character I will try to find I'll try to call my DFS I and j, and we have to take the tree, right? The character we have to insert first on the try. We have to insert these ports on the try, right? What I'll do here, I'll loop for word in words, and what I'll do here, I'll create root first. Root is equal to try node. We have taken the constructor new dot try node. That's try node. It's just try node. We have created a root object. Now I'll just root dot insert the word. This will create a prefix tree of these words we have here already. Now what will do here, this will take I and j, index the board and the root or node, I will say node. Let me write here, you will understand. Now what will do here, I will run that DFS. I will run that DFS first. So definition DFS index I j and the node. I will return if this I is out of bound. So if I less than 0 or I greater than equal to 0, I greater than equal to those, or I j greater than 0, less than 0, or j greater than equal to cos. If this is the case, I will or 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 what, or now we have to check that if this is not case, we'll check that if that particular character like board of, okay, we want one more thing. Let board of I of j is equal to what we will check. Okay, board of I of j not in node. If that is not in node, like consider the case where we are trying to loop through this n and we do not have n in the tree, it will return. Or other thing what we have to check, uh, yeah, we have checked already, we are out of bound. We have checked already that board is not in like the character is not in node. What else we have to check? Nothing. Let me write, if I remember I will write, then return. So here it wants one more character called word, so it is basically current word. So for the first time word will be the empty. Okay, now if DFS, the first time word will be the empty. Now it will check that, okay, and also we'll check that we are not visited. So we will create, because we cannot check same characters again. This will create a circular loop. So let me create a set and a visited is set also, and result is set, and visited is also set, because we can have duplicate. As solving this problem here, summation you can see here TLE, and TLE is getting because I am storing duplicates character, not TLE. It's a wrong answer because I was storing duplicate answer. That's why I have created the set here, and I'll check that or this word of I or this word of I not in not word of I j I comma j I comma j not in set or visited. This is the case if it is in visited, then I will return. Otherwise, what will do? First thing I will update the visited. So visited dot add these two thing I will add I comma j new I comma new j. Now it will do here. Now I'll check that we are here. It means that we have the character is in try. The character is in try prefix tree. So I'll try to find new node. So node will be the um, node will be the new node will be the node of board 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 of I of j. This is a new node, and I try to check that if node is end of node we are end. So node dot is last. If this is true, then I will append into my answer. So result dot append, that is add word or current word. Or if this is not true, uh, let me add first the character to the string first. So current word dot append this ch this board of I comma j. Current word is string. Can you append string into word? I'll just like this thing. We can't do that. So I'll do like this. So see what I've checked. I've checked that if this is not out of bound. I'm saying that this is not out of bound. So this first it will check that this index is not out of bound. Then we'll check that board of I of j, like that character is not in the node. If that character is not in the node, there is no need to go forward, and I'll check that if that particular character is visited or not. If not visited, I will add first, then I will update my current node, and I will update my node as well. Now I'll check that node of children, it is children not node, because this is stored as a children, right? So node dot children. I have updated a children node, and I have updated the word. Now I'll check that if that word is the last, I will update into the my result. And now what I'll do here, I'll call this DFS part. So see here DFS part. So how DFS will go from each character here, it will go top, left, bottom, right. So okay, we can define this direction. Now I'll loop through it. So just loop it for direction in direction in directories uh, DFS I plus direction of 0, j plus direction of 1, comma word, current word, comma current word, comma node. What is node here? Node is that particular thing we have updated node. That's it. And after doing all this stuff, we are end of the, we have put all the character in the string. Not all, just we have done here already here. Now I'll just return the DFS result. I'll convert it to list, then result. So first I was I was going all possible way, like all I have like firstly when I was solving with DFS, I was going all possible character, K as well, R as well, V as well, L as well. But when I have used try prefix tree, what happens that it reduces some time because that A and N is not in the tree. If you are trying to find this word, if you're trying to find this O A, if I have O here, there's no like there's no what there's no need to go to E, that is not in the word, right, in the try. mm, and like in the recursion what we do wish to do, we do wish to have iterate all over the characters. That was I understand. Let me test again. Let me just ask him. Let me test for this. We are looping through each word. So we are looping A O N. So we are O at the first index, we are at O. We are sending 0 0 and 0 0. I am sending 0 0 first, and 0 0 is not in the visited. And this is false, this is false, this is false, this is false, and this is also false. What I'll do, I'll just add it. Let me submit it first. Root dot insert. Insert will take two variable, self comma word. It's root. For the first, I will send root, not node. Node is not defined. I am not asking mode. It's node. Node dot children. I have to check. Not in node dot children. Then only I will be moving forward. Lot of bug. One thing I have just forget to remove. We have added visited, so we have to backtrack it, right? So when we are backtracking, I will just remove this visited of IFJ because we are done with that particular index. So remove. If I do this, it will work. Now it worked. That, let me use this TLE part. It worked as well. It's like taking a lot of time. Let me submit it. Yeah, it got accepted. It's with 19%, 19% 91. But last time I submitted Last time I submitted it takes beats 46.92. So same question, same. Okay. So same solution, or like I have added something else. But this is how it word search 2 works. You can solve using DFS, totally DFS. You do not have to use any prefix tree. But if you solve that using prefix tree, uh, you can save some time. And actually, how to calculate time complexity? I will ask this person, ChatGPT, how to calculate time complexity. Building the trie O of n into L, and DFS search O of m dot n into 4 to the power L. Detail breakdown. Building the trie, we have n number of words and average length of each word is L, so insertion of each word takes O of L. So building the trie each O of n cross L, it's correct. Now DFS on the board, we have m number of rows, n number of columns. So for each word we have m cross n starting point. Yeah, you're right. And for each DFS path, potentially explore 4 choices per cell. So for up, down, left, right, up to the length of the word L. Yeah, you're right. So 4 choice up to the word of the length, exponentially in the length of word. So DFS time will take m to n for all the board and 4 to the power L, because we have 4 choice and we will be doing until the length of the that word. So why 4 to the power L? Every move have 4 choices and depth up to L max word length, that is O of 4 to the power L per starting DFS. The total time complexity will be the O of n cross L for trie insertion plus m cross n. This is the area board into the for each insertion, for each character, like matching character, we are reaching to the 4 to the power L. So this is the time complexity. What is the space complexity? Trie storage O of n cross L, visited set O of L, max depth of the length of the word, yeah, and output set O of n for all word. So O of n cross L plus L. Yeah, so time complexity we have already here, n cross L plus m गुणे L into 4 per L. It is correct, but space complexity I have doubt. Here is, I'll tell him that we are doing recursion, right? We are doing recursion. So each callback function will take some space. So final space complexity O of n into L plus L. Yeah, it is right now. I am saying that trie storage of NL, visited set this one, output set this one. Overall O of n cross L, trie storage plus L. Yeah, this is a 2K. So this is how time complexity we calculated. So thanks for watching. We'll meet tomorrow, and until keep watching, and thanks for the support you have given. We are 22 subscribers till now, and we'll be keep growing, keep growing, keep growing. So yeah, and the exam test, the interview is going well, but I'm not clearing the interview. I have to work on myself. So I hope that you're doing the same thing. uh, Thanks for watching. We'll meet tomorrow. Bye bye.